The second example, it is considering the magnetic system of the first example that I have covered in the previous video, and it is saying that if we have a current the 1 ampere current is flowing, current of 4 amperes is flowing in this coil, and the length of each air gap is 1 millimeter. Find the flux density in the air gap. So what will be the flux density here? We have to calculate the flux density in the air gap. Now this question, if you will see the book, has been approached by different methods, a trial and error method, load line method. But one method that I would like to propose here, it is also a simple method, and it says that the equivalent circuit of our proposed electromagnetic system is like this, where this is the reluctance of core and this is the reluctance of air gap, and we have force F. Now let us assume that our air gap is the area which is consuming all of our magnetomotive force, because core is a very good material. So most of the magnetomotive force will be used here to move the flux through this area. So let's look at what will be the total magnetic motive force in our system. We have a current of 4 ampere flowing, and the total will be 2000 ampere turns. So now the current is 2000 ampere turns, and we also know that if for the air gap, we can say that if equals to Hg into, we have seen, Lg, that is the length of the gap. Now the magnetic field intensity H of G is actually equals to B over mu naught, as it is air gap. From where do I get this? I get this from mu naught over Hg. So G is for gap, gap is the air gap. That is why we are only writing mu naught, because for air mu r is 1, and this is actually the permeability of the air. So Fg is equals to B in the air gap over mu naught into LFG. So we have to calculate the flux density. So let's see, Bg is equals to mu naught into Fg divided by LFG, and this will become 4 pi into 10 raised to power minus 7 into 2000. And what is LFG? Where we have two air gaps, the length of one air gap is 1 millimeter. So this will be 2 millimeter into, and for conversion to meters, it will be like this. So when we will do this, the answer will be Bg is equals to 1.256 Tesla. In this case, we have assumed that whole of the force was dropped over the air gap. That means whole of the magnetic field being produced in this coil was used to move the flux through this air gap. Why? Because here the air gap, the reluctance was very large, so most of the force was used to move the flux, and we have calculated the flux density. I hope this becomes clear. Thank you.